Right then, a solenoid point motor. I'm just going to call it a PM. Essentially what you got on a solenoid point motor is you have two magnets. One that side, one that side. You have a bar running through it. And then you would have an arm. And essentially what you would actually do is, I will draw this out, you have three inputs. Now what can I use for my AC? Right, I'm going to stick to red and black for an AC. I use 16 volts AC, but I don't see any reason why you can't use DC as well. But in my system I use AC. I'm still old school. AC's on the back of your gauge master controllers, and there are other controllers out there as well. So you've got your red, you've got your black. So what you need to do now is you need to wire these point motors up. So on one side of the solenoid point motor you have what you call your common. And essentially that wire is that, them two solenoids soldered together, and that will then go to your red on your AC. Now then, we will have, I'm going to do this as yellow. You have a yellow wire coming in here. Don't know if you can see that yet. I think you can just about see it. And I'm going to do a blue wire on this side. We'll draw it as a switch. So that's my power coming in. So essentially what happens is, if that wire touches that blue line, that will fire that way. So blue will fire that way. If that black touches the yellow line, your solenoid will fire that way. So this is why you often have three wires coming off a solenoid. It is that simple. So let's have a look, shall we, at what I've done earlier. This is a SEEP point motor. As you can see, I've got my blue wire, which will fire it that way, my yellow wire, which fires it that way, my grey wire, it's got a little PCB under here, and that joins it all up. Now this is a SEEP PM1. Now the PM1s have a built-in switch, and I don't know if you can see this, but if you look carefully, just here, that pin moves and it literally joins them up. So you've got a lead in there, a lead in there, and the idea is it acts as a switch. And in theory, there is no reason why you could not use that for your frog. But there's a snag. Engage, it isn't reliable enough. Not for me anyway. I don't know if anybody else has had them working, but on an engage point it has got a very, very short throw, and the actual throw of a point is maybe about 2 mil. Right, I'll show you what I mean, guys. The throw of the point, that distance there, that is probably 2 mil, which means that is literally only going like that. And you look at this, you look at the switch element, in my mind it's got to go that touch further. So to actually wire this up, you've got to be bang on. Well, we're going to power this up first, and we'll see it in action. Right then, this is just a gauge master. It's an M1, I believe. It's just a transformer, 16 volt, twin output. I'm just going to use this, and we're going to crack on with that. Right then, so I've wired my red wire to my grey, as in the diagram. be black. When I touch the blue, it'll fire that way. When I touch the yellow, it'll fire that way. So let's have a look, shall we? If I can hold this. Right, as you can see, red wire is going to grey. If I touch the yellow, it should go this way. If I touch the blue, it'll go the other way. There you go. Right, this method, I'll turn my supply off, not short anything. So this method is actually called stud and probe. Pico sell it. You'll have seen them on several control panels on exhibition layouts. But essentially, that would go to your black wire, and it is just a wire soldered on to a little bit of metal. These are the metal contacts. These would go through your board. This is what that touches. So in this case, you would put a blue one to one of these studs and a yellow one to the other stud. So you'd have a blue and a yellow. You'd come along, you touch that, it will fire, you touch that, it would fire. That's the stud and probe method. You don't have to use these. I've used brass screws in the past and soldered underneath a brass screw. These things I've just used a little bit of metal rodding, and I've used a biro. There's plenty of ways you can actually make these things. Very, very simple method. Now, another method you might decide to do is you could do the push button technique. So let's draw this technique. So you've got your common coming up. That's your stud and probe. What you will do is you'd have your yellow wire and your blue wire. Then what you do is you actually have a switch, and you have a switch, it's a push to make switch like that, and the other contact will go to your black. And I will show you one of these buttons. That is just a simple push button. You get them in any colour. I think you buy them in 10s, get them from China or any decent suppliers. One of railway shops may have them, electronic shops will have them. It's just a simple push button, and that is how you would wire it up. So those will be the little legs. And simply, one goes to yellow, one goes to blue, and the other legs go to your black. So that is another method of doing it. Or the third method is this. Now this is a centre sprung switch. Now it has to be a centre sprung switch. So let's have a look at this, shall we? So it's a centre sprung toggle switch. What I mean by that is I'll push it that way, let go back to the centre, and that way. And I've already got one pre-wired. So as you can see in the wiring, your black goes to your black on your AC, you've got the blue and you've got yellow. Let's turn it around the same way as the diagram. So that'll make it go that way, and that'll make it go that way. So we'll have a quick look at that. I'll wire it in and we'll see that in action. So as you can see, I've got this switch wired up now to this point motor. Push it that way, fires that way, bring it back, and away we go. So that's your solenoid point motor. Now then, downside to solenoid point motors: if you keep your wire connected in one direction for too long, it will burn your point motor out. So you have to pulse it. Pulse is good. You hold on to it, is on. Now then, people will say you should use a CDU with your point motors. So what does a CD use? Right, a CDU, that is a capacitor, discharge unit, which is a CDU. Essentially, you'll find a circuit, it'll have maybe a big capacitor on it, could have two capacitors on it, and it will have an in and an out. Essentially, one wire will go in, so you'll have one wire coming in, it'll go through the CDU and it'll come out. What does it do? It gives a sharp short burst with extra power. Essentially what it'll do is, your capacitors are a bit like a battery. They'll store the energy in there. When you trigger your point motor, it gives it a big whack, and it gives you that burst which will fire your point motor over. Now the beauty of CDUs are you can wire more than one point motor at a time. So if you wanted to change 3 point motors simultaneously, a CDU will give that power to change 3 solenoid point motors straight away. No issues at all. But people swear by these. In my mind, it's because they give a short burst. Doesn't matter how long you touch it for, that will just give a burst of electric. There'll be no damage to your point motors. But in all fairness, I've been using solenoid point motors probably for at least the last 30-40 years. I've never had any issues. I've used CDUs in the past, but if you're only powering one point motor, as long as you remember just a pulse, just a quick tap, job's a carrot. That is all you need to do. If you want to be on the safe side, go for a CDU. I'll chuck a few pictures up of a CDU for you to look at. As I said before, this switch on these aren't reliable enough. You've got to center them spot on. Double O, you will have no issues. You've got enough swing on that motor. Engage, you just haven't got the swing. Forget about it. Use an alternative method. I'm going to use a 12 volt latching relay. So you've got a 12 volt latching relay. Essentially, you got a relay like that. It has 6 pins at the bottom. This is the type you want to look for. And in my case, the top pin is the common for the switch. So it will go something like that. And then it'll be that way. But it can also switch to that way. Right, you've got 2 pins here. and you've got 2 pins here. One we're going to call, I might have these the wrong way around, but it doesn't really matter. You've got a reset and a set pin. So that is currently in the reset position, so we'll call it R, and that is in the set position. And here you've got a feed to your coil, and your coil actually determines which way these go around. Again, like the point motor, you need to join these 2 up. So we'll join these 2 up. Now then, because it's a relay, I'm going to add a diode into it. A diode will ensure that there is no feedback. On this side, again, you need to add a resistor. And I would use a 1K, and I'd probably use a 1 watt resistor. That'll be a 1N004, I believe they are, something like that. Typical resistor. If I've got it wrong, I'll make a note of it. And again, you will have another diode, like that. Now then, this essentially is the grey wire, and then you've got your blue wire. So we'll have that as the yellow, and we'll have this as the blue. Same colours as the point motor, if you notice. But I will show you the point motor. If we look back to this one, you've got your yellow and your blue and your grey going to that. That is what I am doing here. That is exactly the same way. You look at that. So again, this will then go to the red on my AC. This will then go to the black. And again, this is pulsed. So again, I've got my black coming in like that. I pulse that, it will actually fire to the reset position, which means your arrows are up on both sides. If I hit the yellow, that's the set position. The contacts will then move to the bottom. So essentially, that is exactly the same wiring as your point motor. Now you can get some of these latching relays. I think Gauge Master do a circuit. I think they're probably about £5 or something like that, £5-6 each. I built this circuit and I reckon it's probably cost me in the regions of £1.50 to make. Very, very simple. This is what your latching relay, this is what a latching relay looks like. It's a 2 amp 30 volts DC relay. It'll take 1 amp 125 volts AC. If you notice, it's got 5 pins on one side, 5 pins on the other. And I will show you what one of these looks like when it's wired up. Now I've added some LEDs to this circuit, so when I power it up you can see it in action. But essentially that is your circuit. If we look at this here, you can see that's my diode covering them 2 pins. On this side I've got my resistors, because these are where your coils are for your magnets. My diodes again, make sure you get your diodes facing the right way, and that goes to my blue and my yellow. So I'll get this wired up. I've done a simple circuit here. All I've done here is I've got an input, I've got a, so that's your plus coming in, that then goes to an LED, and I've got that one going to an LED. Do the little symbols for your lights, guys. And then that goes to your negative. This is just a separate supply, just showing you how this switch works. So the reason being, if you look at the other side, I have wired a green wire, a black wire and a red wire. These are what will go to your points. You don't need these lights, but I mean, having said that, you could use them on your control panel, showing which direction your point's actually facing. So there's no harm, it's always useful knowing it's there. So in this case, the green will go to my frog, the red and the black will go to my DC bus. In theory, what will happen is, depending which way that switch is, it'll feed either the red or the black through the switch to the frog, and that will power up my frog or my point. And this is what I am going to use. But let's see this circuit in action, shall we? So I'll get this wired up, I will be right back. Right then, so we're wired up now. I've just literally got a power feed coming off my little battery tester. And you can see I've wired my switch in. You can see the blue wires coming out, going to my switch. It's just a case of flick it one way, switches to the red, flick it back, and it switches to the yellow. It is that simple. So just think of this like a point motor. It works exactly the same. Now then, what I'm going to do is I'm going to add them both together. So when we come back, I will have it all wired up, we'll have a point on, and we'll see it working. Right guys, so here we have it. This is the circuit. Now then, if I got a little point motor switch here, so if I switch that, switches the point, switches the light. If I do it back, again, switches the point, switches the light. This is route indication that you may choose to use on your panel or your mimic board. Obviously your switch will go on your mimic board. Your lights I'm obviously powering just off my little battery tester. It's just a separate input to my lights. And this is essentially what I've done. I've actually put, let me get my pen. So you've got me common, that then feeds to this. One common goes to my diode, which is obviously my latching relay. The other common goes to the common on the point motor. Again, the blues, I've got the blue from the point motor, and the blue also feeds here to this diode here. Now then, you say, where's your resistor gone, Tony? Well, I made a fundamental error, didn't I? When I first built this circuit, I had the resistor there, fired it across, the switch did not move in the relay. And I thought, what the hell is going on here? And then I realised the solenoid itself is taking the power. And in essence, the resistor was only there to protect the diode, the relay from getting too much power. But because a lot of the power is going to the point motor now, I don't actually need that resistor. Once I took the resistor away, diode's quite happy. And that was my workaround. It was a fundamental error, but essentially, because I've got the solenoid, I don't need a resistor because I'm resisting the power through my solenoid. Simple as that. Took a little bit of head scratching, but I got there in the end, guys. And we'll just have a quick look at the underside. So, my point motor is underneath, and I've bolted it on. Well, this is a little trick I've learned along the ways. What I do, instead of screwing your point motor up, I put a bolt through, then I put a nut on. I don't know if you can see that. Yeah, there's the top nut. And I do the same on the other side. Put a nut on the other side, then I slip my point motor over, and then a couple more nuts to secure the motor in place. Now then, why have you done that, Tony? Well, it's simple. In the future, if a point motor ever fails, I don't have to unscrew it. I just unscrew the nuts, wham another point motor in, screw the nuts back on, job's a carrot. I can pre-wire it away from the board, slip it in, wire it back in. Not an issue. And this is a very useful trick, especially for those that have got the mobile layouts, those that are going to exhibitions with the layouts. It's a very quick way to switch a point motor. I've done this with all my point motors. So that's just a little trick that I've actually learned. So it's down and dirty. Obviously all this would be under the board, all this electronics normally, but it just gives you an idea how the latching relay works with the wiring for the point motor. Now it's a latching relay, so it remembers the last state it was in. As you can see here, these would be my feeds to the track. The green goes to your frog, the red and black goes to your track. Now remember guys, this will work for DC and DCC, because all it is, it's an electronic switch. No, I'm not using a frog juice, I'm not using any magic like that. Now then, one thing I will say, because it's not easy when you've got your wiring under the board and you're trying to remember, oh, what colour frog is that, which wire does that need to be in that direction. What I would do to start with, if I was wiring this up, I would wire all this side up, put your wires on, don't wire it into your board yet. I would fire it once and fire it back again. The reason I would do that is so you know which position that switch is in relation to your point motor. Your frog is always going to be the same, because that's the input to the switch or the output, whichever way. In essence, as you know, I'm using the switch in reverse. So the frog wire is going to be the same. Now the black and red, when you wire these first up and you wire it to your board, you may get a short and you're thinking, what the hell have I done here? It's simple. You're feeding the frog with the wrong side of the power to your rail. And it's just a case of you may need to swap these two over. Once you swap them over, happy days, it is sorted. Or of course you can just use a continuity tester. Right, so that is my point motor demo with the latching relay. And just to clarify things, this here is the circuit diagram. We'll go in a little bit deeper for you. So there you go. So as you can see up here, I've got I use the 16 volts AC, and to be honest guys, that is why I'm using these diodes. It's good safe practice to use a diode anyway, but because it's AC as you know goes up and down, up and down, up and down. This in effect rectifies the signal a bit, and it also protects the coils so you're not getting anything feeding back through your coil. So it's a good form of coil protection there. Those are the wires going to my track and my frog, depending on which rail is which on your layout. That bit there, that was just my LED indicator. I've used a separate power source, as you know. If you are going to use the LEDs, don't forget you will need a resistor for your LEDs. What I did, I put my resistor on the one leg going in, and then you don't actually need any on the LEDs. Again, it's standard practice. You're using LEDs, you do need to add a resistor to them. If you put 12 volts straight through an LED, it's just going to pop. That's just LEDs for you. Got to resist your LEDs, guys. Do not forget that fundamental mistake. But as you can see, my grey wire, which I've done in my previous sections, goes to the common on the point motor, goes to the common on my latching relay. I have my yellow wire on one side of the motor. That also is wired up to my diode there. I have my blue one, blue there. And again, that comes, my other wire goes down and that's my switch. Be it a toggle switch, be it a push switch, be it your stud and probe. So there you go guys, that is what I've done, that is my workaround. Now then, before I finish this, I would like to point out there is two people that obviously produce a similar circuit. You've got your gauge master, they do one, and this relay is mounted to a PCB. Now as you know, I'll get you the relay out. This is the relay I've used. See that before? And I've literally soldered all my wires onto it. Now the problem I have found is these pins are very, very tiny, and if you're not careful they can break. Now if your board is a static board, never gets moved, you're going to go nowhere near that wiring, it's never going to get knocked, happy days. This is a cheap way of doing it. Now then, what I'm going to use, and it's a little bit more expensive I know, but I'm going to use this PCB. This is from Modelling Electronics, and that's what it looks like guys, this PCB here. Essentially they've soldered it to a board, all the outputs is what I have got here, but they go into a screw block terminal. So now I've got no worries about breaking any pins off this. And this particular one is wired up like this. On this pin is your common. On this, it doesn't matter which way these two wires are. We've got your blue and you've got your yellow. Just remember, I'm doing AC guys, so I have a diode coming in here, and on this the diode goes the opposite way around. As I say, it's good practice really to put your diodes in. Now then, on this side, these are these 6 pins respectively down here. I'm going to call these top 2 are your inputs. So they're that pin and that pin. So we'll call these ins, and we'll call that A, we'll call that B. Now then, the bottom 4 are your outputs. Now according to my the circuit diagram on the website, I have just shoved a link for the website up. Essentially, if I remember rightly, that and that is one of your connectors, and that and the other 2 are the other ones. I may have this the wrong way around, but if I remember rightly, it goes A, B, B, and there, that little bit there. So the outputs are these 4 pins at the bottom. Just check on the website. These guys, Modelling Electronics, are also on eBay as well, so you can actually get the units on there. And to be honest, if you're actually going to order more than 2 units, it actually works out cheaper to buy them on eBay. But I didn't tell you that guys, you just got to remember your postage and everything as well. But yeah, I may have those the wrong way around, it may be BAAB, but there you go. That's your ins, that's your outs. This I can screw directly onto my board. You actually get some pillars as well, some PCB pillars. They come free with it. So you could actually screw, bolt them under the board, but that's what I think of them. So there you go guys, that is the unit I'm going to go for when I do my main layout, because my main layout is a portable layout. So it's going to get bashed around if it ever does go to an exhibition. That is the way I'm going to do it. I can just screw all my wires in here, easy peasy, lemon squeezy. So I will have to purchase a few of those for my main layout. But that essentially is how I am going to control the frog on my solenoid point motors. So I hope that helps you out guys. I will catch you in the next one.